greeting to Dr. Kavita and my fellow friend. My name is Nurul Nazira. Together with my teammate, we will be presenting on our finding of research study. Our research study is about estimating post-mortem interval of road traffic accident. This slide shows that the detail of our main reference. The research paper explored the use of microRNA as a potential marker of estimating the post-mortem interval (PMI) in the case of the road traffic accident. PMI refers to the time between the psychological death and the discovery of the corpse. Estimating PMI accurately is challenging, particularly in advanced stages of decomposition. The study focused on miRNA, small non-coding RNA molecule that play a role in gene regulation. miRNA have gained attention due to their stability compared to other RNA species and their potential as marker for PMI estimation. The researcher specifically analyzed mRNA 195, mRNA 206, and mRNA 378 in heart tissue sample obtained in autopsy case involved road traffic accident. The challenge of PMI estimation is limitation beyond 72 hours necessitating alternative approach. As for connection for mRNA analysis using QRT, PCR is well-established and widely used technique in molecular biology and clinical research. This feasibility makes it a practical and accessible approach for routine forensic analysis. Forensic laboratory equipped with QRT, PCR instrument, and expertise can readily implement mRNA analysis as part of their PMI estimation protocol, improving the accuracy and reliability of forensic investigation of road traffic accident cases.
Hi, my name is Umi Maisara binti Abdul Hadi. Let's continue with the materials and method of this study. In this study, 20 samples from forensic autopsies of road traffic accident cases were involved, in which the deceased were from the age of 18 years old to 32 years old without any antemortem disease. Then, approximately 5 grams of the heart tissue was removed from the left ventricle, and the samples were divided into 8 sections and then stored at -80 degrees Celsius for different time intervals until further processing. Next, the heart tissue sample was homogenized with 1 ml of triazole. After that, the RNA isolation was done to precipitate the RNA and proceed with the cDNA synthesis, which can be described as generation of complementary DNA using the Taqman Advanced microRNA cDNA synthesis kit. The procedure continues with the real-time PCR reaction, which is the gene expression detection process. After that, the data obtained were then normalized, and lastly, the CT values were analyzed to calculate the relative expression levels for all selected microRNAs at each time interval.
Next, I will be explaining the results of our research paper. Now, if you look on the left side, it is a dotted plotted graph that represents the differential redistribution of microRNA levels that comprises of the mean and standard deviation. Now, particularly on this graph, it represents the microRNA 195. As you can see, the expression level of this microRNA 195 is lower when compared at the 12th hour to the 196th hour, where its p-value is lower than 0.001. Next, it has a moderate to large effect size with a range of 1.26 to 0.8. Lastly, it can be said that this microRNA has a significant role in the PMI estimation. Next is the microRNA 206. Similar to the previous one, it has an expression level lower compared when 12 hour to the 196 hour, where its p-value is lower than 0.001. Its effect size ranges from 1.33 to 1.08, and it can be said that there is a low amount of variability within each group when compared to different groups, and it has a stronger impact of the PMI estimation compared to the previous one. Next is the microRNA 378, and similar to the previous two, it has an expression level lower at 196 hours compared to the 12th hour, and its effect size can be said to be moderate, where its value ranges from 1.22 to negative 1.04. And if you can see closely, there is a considerable degree of variability within each group. Now, what can we interpret or what do we understand from the association of microRNA expression with time? There are three main points, and the first point is that there are significant differences between time points with all three variables, and microRNA 206 shows the largest effect size. Moving on to my second point is that these changes shows a pattern of deterioration. We can clearly see it from the 12th hour to the 196th hour. Lastly, all of these expression of microRNAs significantly is associated with increasing PMI. As the time goes by, the microRNA levels decrease.
In this study, heart tissue is used as the sample because it has higher PMI stability compared to other organs. This is due to the heart tissue being protected in the thoracic cavity and less affected by the external environment. For the PMI estimation, a good estimator of PMI should have significant and measurable levels of expression. Slow degradation with increasing PMI is useful for cases with prolonged PMI. The most ideal endogenous control also needs to be selected based on its ability to be expressed at constant level without being influenced by PMI, cause of death, and individual parameters. In this study, microRNA1 is used as an endogenous reference marker as it is the most ideal. It is stable for 196 hours and can be used as an internal standard for a long time after death. The three studied microRNA were chosen because microRNA 195 has potential utility for PMI determination in the range of more than 24 hours and found to be a good reference marker in mice and human lung tissue. MicroRNA 206 is useful reference marker for skeletal muscle, and novel microRNA 378 is abundant in the heart. Even though it has not previously been studied for PMI estimation, the RT-PCR showed increased sensitivity and reproducibility, while microRNA expression was analyzed with great efficiency. From Table 2, it can be seen that the cycle threshold (CT) values of all microRNAs decrease with slight elevation at certain points. This is positively associated with increasing PMI. MicroRNA 378 elevated at 120 hours before decreasing from negative 0.13 to 0.47. MicroRNA 195 and microRNA 206 elevated at 196 hours, where microRNA 195 it increased from negative 0.12 to 0.08, while for microRNA 206 it increased from 0.47 to 1.08. Referring to the Table 3, comparison between microRNA 195 and microRNA 206 showed a significant difference at 96 hours and 120 hours, where its p-values are 0.043 and 0.031 respectively. Between microRNA 195 and microRNA 378, there are no significant differences, indicating that both microRNA 195 and microRNA 378 showed similar expression. Hence, either one can be used in further studies. Between microRNA 206 and microRNA 378, there were notable differences found in the expression at all intervals except 48 hours, where its p-value is 0.151. In Table 4, the expressions of microRNA 195, microRNA 206, and microRNA 378 over time are assigned at different comparative time intervals. It was found that microRNA 206 was significant in more intervals than microRNA 195 and microRNA 378. Hence, it can be said that microRNA 206 can give better results when examining more samples with increasing time intervals.
In conclusion, miRNA show a potential as stable molecular marker for estimating postmortem interval PMI in road traffic accident cases. Specific mRNA in hurt tissue sample can be analyzed to estimate PMI during the advanced stages of decomposition. The study demonstrates that specific mRNA expression pattern in hurt tissue sample can be analyzed to estimate the PMI during the advanced stage of decomposition. This suggests that mRNA expression level and degradation pattern can provide a valuable insight into the time since death.